This video is on the rate law. So a rate law is an expression for the rate of a reaction and this is in terms of concentrations. Okay, so it's using concentrations to determine how fast a reaction will occur. All right. So then we also are going to have this specific rate constant in our equations, which is a lowercase k. This is the constant for rate laws that relates the rate of a reaction in order to really get the K, you actually need data and do it in the real world. We need to do experiments to get this kind of information. So what does K even mean? If K is a very, very large number, that means it's going to be a very fast reaction, so we know it's going to be quick. If K is very small, that means it's going to be a slow reaction. So I would say a large number would be positive numbers like 8 or even like 600. Small numbers would be more like decimals, or even like 1 would be a kind of slow reaction. So reaction orders. This is going to be a power to which the concentrations are raised and this is to give the rate of the reaction. So really the reaction orders are going to be exponential. Okay, so the reaction orders are the exponents in these kinds of problems. And the reaction order is what we are going to be solving for, along with K eventually. This video is only about solving reaction orders. So this is going to be kind of our base equation. The rate of a reaction is equal to K, which is our specific rate constant, okay, times the concentration of our first reactant, which I'm just going to call A, to the power of M, which is the reaction order, times the power of B, which is another reactant, to the power of N. So this is kind of the base rate equation, and the N and the M, those are the orders of the reaction. Those are the things we're going to be trying to solve. So when doing these order reactions, it's important to remember that they are exponential, okay? So if something is to the 0 order, what does that mean, right? That means A is to the 0 power. So if you had tried to change this reaction and multiplied A by 2, there's actually going to be no change here. And so why is this? It's because anything to the 0 power is going to be 1. Okay, so if I take 1 to the 0 power, that's going to be 1. Okay, 2 to the 0 power, that's still going to be 1. If it's the first power, that would be A to the first power. Okay, so if I multiply this one by 2, that means the reaction will also, and the rate for this particular item will also go by 2. Okay, if it's by 3, it'll go by 3, etc., etc. Okay, so why is this? It's because if something is to the first power, it's just going to be itself. So if I multiply that by 2, it's just going to be 2. If I multiply 1 by 3, it's just going to be 3. Okay, so something to the first power gives you the same number. And last part of this first notes before we go into our actual examples would be second order, so a to the second power. So if you multiply something by 2, that means that the rate will actually multiply by 4. If you multiply by 3, the rate will multiply by 9. And that's just because 2 to the second power is 4, 3 to the second power is 9. Okay, so just remember they are exponents. So these reactions will also ask you to find what is the overall rate of the reaction. So what is the overall order? And all you have to do to find this is add up the different exponents. So this will be kind of the last step of our problems. So basically you have to take the m plus the n, and that'll kind of give you some kind of total for the overall. There's also some cases where there's more than 2 things, so it might be like m plus n plus p plus, there'll be a bunch of different letters. All right, so let's get some of these examples. Hopefully you already have this chart copied down. If not, pause the video, copy down the chart to help you with these problems. So what we're going to be doing is looking for things that are the same, because things that are the same are going to cancel out. Okay, so I'm just going to mark in this first column, these first 2 are the same, so they're just going to get a little mark. I'm going to change the color. And now in the second column, which 2 are the same? Those 2. The first one and the third one are the same. So first thing you should do is mark in the columns which ones are the same. Now, to decide what reactions we are going to use for our math here, what I normally do is I cover up whichever one I'm trying to find. So I'm going to do that with a scratch out. Just hold your hand over this first one. So don't actually scratch it on your paper, but you can just hold your hand over that first one. Now, which ones are the same? Okay, we've marked them already. It's number 1 and number 3. So for this first one, we're going to use reactions number 1 and number 3. Okay, now same thing. For the second one, just hold your hand over H2 and cover it up. And now we can see that reactions number 1 and number 2 are the same. So those ones will cancel. All right, so that is how you decide which reactions to use, which is actually the hardest part of this. It's just deciding what to use. All right, so let's look at some actual math here. So I'm gonna do reactions 1 and 3 first. So the rate of a reaction, we're going to take rate 1 over rate 3. And I'm going to use that equation I gave you above, where we're going to take K multiplied by A, which in this case is going to be NO, and that's going to be to the M power, multiplied by B, which is H2 in this case, to the N power. And that's going to be over, it's going to be the same thing on the bottom. The top ones are going to be for rate 1, and the bottom ones are going to be for rate 3. All right, so now we're going to plug in some numbers from our equation. So I'm going to start with the rate 1 and plug those in to rate 1. So K is equal to 0.210 to the M power multiplied by 0.122 to the N power. All right. Now I'm going to plug in rates for 3. So the third one's for the third reaction. So we have 0.42 to the M power times 0.122 to the N power. So all I do is plug in numbers there. And now we have to mathematically solve this problem. So when doing this, kind of like in math, if you have something that is like 2 divided by 2, that's going to equal 1, right? So we can basically cancel out those 2's. So we're going to do a similar thing here. So anything that's the same, we can cancel. So k is the same, and then this 0.122n is the same, so we can cancel out all of those different things. So we're left with just 0.210m is over 0.420m. So that's why we were looking for things that were the same originally, because we wanted them to cancel out. So I'm just going to take that 0.210 divided by that 0.420, and this is still to the m power. We're trying to find m. So when you take 0.21 divided by 0.42, you are going to get a half. Okay, it's critical that you keep these things as fractions. Do not use decimal places. Okay, so that's 0.5, which is a half. So now, how are we going to solve for m? Well, we need to use the rate 1 and the rate 3. So I'm going to use the rates in our top equations up here. So we have rate 1 and rate 3. So we're going to divide 0.0339 for rate 1 divided by 0.1356 for rate 3. And that's going to equal to 1 over 4. So that means that 1 over 4 is equal to 1 over 2m. So what is m, right? So this m is basically kind of distributed, so we can think about it as with the m's here. So what should this m be to equal 4? Well, 2 to the second power is 4, so that means m is equal to 2. Alright, second part is now we're going to do the same thing with reactions 1 and 2. These are pretty long problems, okay? So same exact thing, except we're going to use rate 1 and rate 2. Okay, so same thing. We have K to the NO, M, H2 to the N. Those are going to both be for rate number 1. And that's going to be over. Same thing, except now it's going to be for rate number 2. All right. So pretty much the same thing as last time. We're just going to plug in the numbers for 1 and 2 for this time. So 1, going to plug in 0.210 and 0.122. All right, so now we're going to plug in the reaction number 2. So that 0.210 and that 0.244. All right, and we're going to cancel out what is the same. So K's are always the same. So the K will always cancel. And now we have this 0.12m is the same and 0.12m is the same. So we're going to get 0.122 divided by 0.244. And that's going to equal 1/2 n. So to find n, we need to look at rates 1 and 2. So we're going to take 0.0339 divided by 0.0678, which is equal to 1/2. So if 1/2 is equal to 1/2 n, what should that n be? N is going to be equal to 1, because 2 to the first power is 2. So the overall answer to this question would be that m is equal to 2, n is equal to 1, and then the overall, we would just add those two things together, is 3. Okay, so that would be the final answer for this question. Okay, so let's look at a second example. Maybe pause the video at this time and try it out, see if that first one made sense to you. So I'm going to mark first which ones are the same, in each reaction. Okay. And then, remember, we're going to hold our hand over that first one. Just hold your hand over it. And then we can see that we should use reactions 1 and 2 for this first one. Okay, so same thing. You're going to hold your hand over that OH column. And you can see that we should use reactions number 2 and 3 for the OH. All right, so let's get rocking here. So we have rate number 1 and experiment number 1 and experiment number 2 that we're going to use. So we're going to get K is equal to that ClO2 to the M power for the first one times OH to the N power for the second one. Okay, those are both for the first reaction. Now, same thing. The only difference is that this one is going to be for the second reaction, but basically the same. Okay, now I'm going to plug in those numbers for our first reaction. Okay, now I'm going to plug in the numbers for the second reaction. And now we're going to look and see what will cancel. So K always cancels because it's the same, it's just K. And this one, this 0.03N is going to cancel. So we're going to get 0.06 divided by 0.02, which is 3M. When you guys do these questions, you should always get whole numbers or like normal fractions, like answers like 2, 4, 9, 3, like those kinds of things. Or as a fraction, you will get like 1/2 or 1/3. Okay, they should be whole numbers. So we're going to take rate 1 divided by rate 2. And we're going to take that 0.02484 divided by 0.00276, and you should get 9. So 3M is equal to 9. That means that M must be 2, because 3 squared is 9. So now let's look at reactions 2 and 3 to find the N. So reaction 2 over reaction 3. So we're going to take the second ones and put them over the third ones. And now I'm going to plug in the numbers for reaction number 2. And I'm going to plug in the numbers for reaction number 3. All right, so look and see what cancels out here. So the K cancels and the 0.02M is going to cancel. So we get 0.03 divided by 0.09, which is going to be 1/3. Remember, keep them as fractions. It'll be very helpful to you. Then we're going to take rate 2 divided by rate 3. And that's going to give us 1/3 as well. So that means that this N must be equal to 1. All right, so that means M is equal to 2, N is equal to 1, And our overall for this reaction, remember to add them up, is 3. All right, last example. This one has 3 different elements in it. So we're going to do the same thing. We're going to mark which ones are the same. So this first column is also kind of strange because there's 2 different things that are the same. So I'm just going to mark those kind of independently as being the same. So 1 and 4 are the same, and then 2 and 3 are the same. Okay, second column, which ones are the same? We have 1, 2, and 4. And then last one for the third column, we have 1, 2, and 3. All right, so we need to decide which equations to use. Basically, the only difference this time is now we need 2 things to cancel out, not just 1 thing. So we need double canceling. So hold your hand over that first reaction, and let's look at the other ones. So we're looking for things that are both marked in both columns. Okay, so in experiment 1, both of them are marked, and in experiment 2, both of them are marked. In experiment 3 and 4, there's only 1 of each marked, so that's not going to work because they're not going to cancel. Okay, so that means for this first one, we're going to use 1 and 2. All right, now we're going to hold your hand over that middle column and consider which ones are marked in both the first column and the third column. So that would be the first one, the second one, and the third one. But we only need 2 for this, so which ones should you choose? 4 obviously not marked, so we can't use 4. Now when looking at these, the third column is all the same, but the left column has 1 that's purple and then 2 that are red. So we need to use ones that are the same, so we cannot use the purple one, we need to use the 2 and the 3 because those are going to be the same. We want them to be the same so that they cancel out. All right, last one, same thing. Hold your hand over that column while we look at the other 2. So the first ones are both marked, the second ones are both marked, and the fourth ones are both marked. Similar to that last one, we only need 2, so it can't be 3. It cannot be 2 because 2 is kind of the odd man out here. 1 and 4 are both purple, so those ones are good. So we're going to take number 1 and 4 for this last reaction. All right, so that is the hardest part of these problems. It's just deciding which reactions to use. Okay, so now we're going to write those reaction equations, and it's the same thing. We're just going to have a third element in them. So I'm going to start with 1 and 2. So rate 1 over rate 2. So still K, and then we have our first thing to the M power, our second one BR to the N power, and now we're going to have a third one, and that one we're going to put to the P power. I know O is next in the alphabet, but O kind of looks like a 0, so we just go with P because that's a more distinctive letter. Okay, so that's the first reaction, and we're going to put that over the second reaction. Okay, and now it's really the same as those other problems. We're just going to plug in numbers, and then we are going to cancel out things that are the same. So we're plugging in 1 first. And then we're going to plug in all of the 2's. Okay, and now we're going to cancel out which ones are the same. So K is the same, N is the same, and P is the same. So those all get canceled. So we get 0.1 divided by 0.2 M, which is just going to be equal to a half. And then we're going to take reactions 1 and 2 and divide them. That 8.0 times 10 to the negative 4 divided by 1.6 times 10 to the negative 3. When you're doing those divisions, make sure you put the top and the bottom in parentheses. But this is also going to give us 1/2. So that means that we have 1/2 is equal to 1/2 m. So that means m must be equal to 1. Alright, so now I'm going to take reactions number 2 and 3. I'm going to do this one a little bit shortcut because I think you guys kind of should be getting the picture by now of what we're doing. So we're going to take rate 2 over rate 3. And so what I'm going to do this time is I'm just going to plug in the numbers right away to kind of save some time. So we're going to plug in the numbers for rate number 2. And on your homework, feel free to start at this step. What I'm writing now is kind of the minimum amount of work that you can have to kind of show your work. So we have rate 2 over, now we're just going to plug in the numbers for rate 3. Okay, now we're going to look and see which ones are going to cancel out. So the K cancels, the M cancels, and the P cancels. So we are going to get 0.1 divided by 0.2, which is 1/2 to the n power. And now we're going to look at those rates for 2 and 3. So 0.16 times 10 to the negative third divided by 0.32 times 10 to the negative third, which is also 1/2. So 1/2 to the n power equals 1/2. So n is equal to 1. All right, last one here, 1 over and 4. So we're going to take reaction 1 divided by reaction 4. Again, I'm just going to plug in the numbers to save some time. So plug in all the numbers for reaction number 1 divided by all the numbers for reaction number 4. Okay, and then we're going to cancel out things that are the same. So K is the same, M is the same, and N is the same. So we're just left with that P. So it's 0.1 divided by 0.2, so that's just going to be 1/2 again. All right, and then we're going to take reaction 1 divided by reaction 4, right? So those rates. So that 0.8 times 10 to the negative 4th divided by 3.2 times 10 to the negative 3rd is going to give us 1/4, which means that P is going to be equal to 2 because 2 to the P, so 2 to the second power will be 4. All right, so kind of to finish off this problem, we have M is equal to 1, N is equal to 1, and N is equal to 2. So overall, 1 plus 1 plus 2 is equal to 4. And I just want to have one last side note that I know students kind of get confused on. If you get the situation where your rate is equal to 1 and you get something that kind of looks like 1/2 m is equal to 1, a lot of students are like, I don't know what m should be. Well, m is going to be 0 in that case because anything to the 0 power is equal to 1.